For a CE transistor amplifier, the signal voltage across collector resistor 5 kilo ohm is 2 volt. If beta is equal to 50 and base resistor is 2 kilo ohm, then input signal voltage in millivolt is. Well, it's been clearly mentioned that across the load resistance our output the voltage is 2 and the resistance being 5 kilo ohm. So the IC here it would be 2 divided by 5000 ampere, and beta being given as 50, so I would say IB, that is IC divided by beta, that is 2 divided by 5000 into 50. This is the value of the base current, and the base resistance that's been given to be 2 kilo ohm. So Vin is equal to I into R. I is equal to 2 divided by 5000 into 50, and R is equal to 2000. This will cancel out, and here we are having 4 divided by 250, or I would say Vin is equal to 16 millivolt. That's the answer. That means for question number 21, 16 is the correct answer. Now let's proceed to question number 22. Here in question number 22, a message signal of 5 kilohertz is modulated by carrier frequency of 1 megahertz. Bandwidth of the modulated signal is. Pretty simplistic and theoretical kind of questions. I guess you all people must be knowing this answer. The bandwidth, half bandwidth, will be oscillating as 5 kilohertz. So from here 5 kilohertz will be in upper side, and from here the 5 kilohertz will be on the downward side. So width of this band, it will be simply 10 kilohertz. That's our answer. For question number 22, 10 is the correct answer. Now let's take on to question number 23. Here in question number 23, two coherent point sources S1 and S2 are at a small separation of 5 lambda, placed symmetrically with respect to center of the circular skein of radius r, that is much more greater than lambda. Smallest value of theta for which intensity at point A is 1/4 of the maximum intensity is cos inverse n divided by n plus 1. We need to find the value of n. Well, this distance being 5 lambda, and here the maxima of 5th order will be forming along this direction. Definitely somewhere around there will be the maximum of 4th order, and in between the intensity would be less than the maximum value somewhere. It's been given the intensity here to be 1/4 of the maximum. So the intensity to be 1/4 of the maximum, the phase difference there, it would be 2n pi plus minus 2 pi by 3. So along the direction, since phase is decreasing, here it is of 10 pi, so I would say the path difference would be decreasing, or 5 lambda cos theta actually is the path difference. It must be equal to 5 lambda here, and decreasing along the direction it would be lambda by 3. So taking this part, I would say 5 lambda cos theta is 15 minus 1, 14 lambda by 3, or cos theta is equal to 14 divided by 15. Comparing this answer with the situation given here, n divided by n plus 1, clearly I would say n is equal to 14 as the correct answer. So for question number 23, 14 is the correct answer. Now let's proceed to question number 24. Two coherent point sources of wavelength lambda are placed at P and Q on X as the shown. A screen is placed at X is equal to D parallel to YZ plane. If D is much more greater than lambda, then radius of smallest bright circle formed on the screen is root under n divided by 3 into D. Find the value of n. This being the two coherent sources, here we are having the screen. The distance between these 2 points are 4 lambda. I would say at this point we shall have the maxima of 4th order. Along this direction the path difference would decrease, and by the time when the path difference would become 3 lambda, again we shall have the maximum value. Question here is to find the radius of smallest bright circle. We shall have the circular bright fringe here. We need to find the distance. I would say if this angle being theta, here it is 4 lambda cos theta would be equal to 3 lambda, or theta cos theta would be how much? It is 3 by 4. So taking this part as this portion being 3, this portion being 4, so this will be 7, this angle theta. So now if this is the radius r that is required for this calculation, I would say r, this being d, so simply r divided by d is equal to root 7 by 3. Or how much is the value of r here? It is root 7 by 3 into d. Comparing this answer with the one provided here in the question, value of n, it is coming out to be n is equal to 7. That's the answer for question number 24. Now let's proceed to the final question, that is question number 25. Here in question number 25, in the circuit shown, the average power delivered to the circuit by the AC voltage source is 19 V0 square divided by NR. Find the value of N. I would say for the first half, when this is the direction of the way the current will be driven, then this diode will be functioning and this will behave like a open circuit. So effectively these 2R or 2R will be in parallel and in connection with series with this R. So effective resistance for first half cycle it would be 2R parallel to 2R, it is R, and in series with R it is 2R. So I would say V0 square divided by 2, RMS value I am taking here, divide by R, R it is 2R, into time how much it is? T by 2. This is the energy dissipated in one half cycle. For the another part, V0 square by 2, this is the RMS value, R effective this time. This time this will be the functioning diode and this will behave like open circuit. So here it is R in series with R, that is 3R, in parallel with R, that is 3R by 4, and plus 2R, it is coming out to be 11R by 4. So it is 11R into 4. Yet again this is for one half cycle. This is the total energy dissipated divided by time. This is the average power. Making the calculation, we'll be getting this answer P average as 19 V0 square divided by 88R. So for the question number 25, the value of N that is coming out to be 88. That's the answer. Well, that's the end of this question paper. I hope you must have understood and appreciated the solution of this paper, and I wish you all the best for your further preparation. Thank you and goodbye.